Good evening, everyone. My name is Tequila Smith. I'm founder and executive director of Science, Engineering, Mathematics Link Incorporated, and I want to welcome you to tonight's Teen Science Cafe. The Teen Science Cafe is a program of our Math and Science Career Academy, whose goal is to introduce teens to different STEM careers by STEM professionals and graduate students sharing their career journey, information about their field, and their current work. So, as you are making important decisions about college and career during your teen years, you can have the opportunity to make informed decisions about if you are going to pursue a STEM career and what STEM career you'll pursue. So I am going to introduce our speaker, Program Coordinator Carlin Pounders, who is going to introduce tonight's speaker.
Hi, everyone. So tonight's speaker is Debbie Gordon, who is a groundwater hydrologist with the U.S. Geological Survey, also known as USGS in Norcross, Georgia. She got her Bachelor of Science degree in geology at the University of West Georgia and her master's in geology with a focus on hydrogeology at East Carolina University. She's been working at the USGS in Georgia since 1994. So Debbie has a wealth of knowledge to share with us, and I'm sure some interesting and surprising things that I'm looking forward to hearing about. So with that being said, Debbie, how do you want to proceed?
Hi. Oh. So can you guys hear me?
Yep.
Okay. If the echo is, can you hear about echo? I can go get earbuds if I need to. How does it sound?
We can hear the echo. It wasn't an echo before. So
yeah. Hold on.
I was like trying to talk and I was still on mute. Sometimes technology and audio
it said something about using earbuds to prevent echo, so I'm going to try that.
Okay. And Debbie, we do see your stream to add your PowerPoint, but it says your mic and camera aren't connected, so I can't add you.
Yeah, the mic and camera are both blocked out.
Wow. That happened to me earlier today.
Did you get my presentation, Carlin?
So it is asking me to log in to access it.
It's asking you to, oh my gosh, to log in?
Yeah.
I don't know why. Okay, wait, it just unmuted me.
Yeah, it says I can add you. Well, no, it went away now. What is happening? Technology. Well, what Carlin can do while we're working your technology. Oh, wait, there it is. Okay, let's see. Oh, no, it won't stay. What we can do is while we're working up your presentation, Carlin can ask you some questions as we are getting your presentation up, because this is going to happen. We are going to see your presentation. Let's see. We are going to see.
Can you see my screen by any chance?
I see your screen, but it's telling me I cannot add you because your devices aren't connected, because your camera and mic aren't connected. Okay, that adds you, but it doesn't add your PowerPoint.
Can you see it now?
I see it adds a second stream, but it doesn't share a screen. It's just you. So I think that's where the echo is coming in.
It says StreamYard is sharing your screen and audio.
Okay, let's see. But what I see is another you, and it doesn't share your screen. So I'm going to take that one out because, oh yeah, you took it out because it adds the audio. So,
Right. All right. So do you think I can put this, share the PowerPoint on Google Drive somehow?
Yeah, if you share it with us on Google Drive, one of us should be able to pull it up.
Okay.
And everyone watching, want to thank you for your patience as much as we are so dependent on technology. Sometimes it just does not go as smoothly as we would like it to. So in the meantime, whatever questions you may have about hydrology or the USGS, put those in the chat, and Carlin will ask Debbie while we are getting her presentation up. Like, I live that far from University of Georgia, and I didn't even know they had a geology program. Like, wow. It's amazing what can be close to your backyard that you don't even know. You're still muted, Carlin.
Okay. That's the second time that happened. I also saw, something interesting about hydrology as it relates to when we talk about sustainability and, just how we are addressing and approaching our environment when we talk about the human impact of our water and our land and our trees and so many things. Um, Hydrology really is so important too. Like, of course, we have a little bit of privilege with, you know, saying that access to clean water comes easily. But when you think about a lot of other places, even in the US and outside of the US, their water management is So we do have a question, Debbie, if you can answer it while you're emailing the question.
Okay.
Okay. So someone asked, how does hydrogeology work?
Hydrology is the study of water. So it's a branch of geology. And it relates to the rivers and streams on the earth.
Mm.
Okay. I think I see your stream again. So do you want me to try to add that? Or do you want to? Oh, I'm sorry. Okay. We do have an echo, so that there's another one that you should come out of. Not your stream, but you have 3 right now.
Okay, what do I have 3 of?
So you have, so I have an echo because you're listed twice in here in addition to the stream. So if you can take your second U out, the echo will go away. Wait, let me see if I can hit. Not that one. Let's see. Oh no, I can't do that.
Get all the way out and come back in.
Okay, that's fine.
Okay, wait, is that better?
No, because you took your stream out and you still have 2 of you. So that's what's causing the echo.
Okay, I'm getting all the way out and I'll log back in.
Okay. Oh, that's a great question, Chloe, and we'll ask her when she comes back. Are you interested in being a hydrologist? Or am I saying it right? Hydrologist.
Muted. I was just talking and I was muted. It sounded like I was saying it wrong though. It sounded like she said hydrology.
Hydrology.
No.
Okay, so there's no echo, so that's great. So now you can just share your screen because your screen was working perfectly.
Okay. Share screen. Share audio.
Okay.
Ooh,
And I think before you were sharing it from Google Drive and it was working really, really well before you logged out.
Oh, really? So you can't see my screen?
No, we see your log in. I mean, like your StreamYard. So before you logged out, you had your stream was showing your Google Drive and the presentation was coming up.
Okay, I'm bringing it back up, I hope.
Maybe unshare your screen and then put it back up. Like have the tab for the Chrome.
Okay. So stop sharing.
Yeah, stop sharing and then open it back on your Chrome. And then once it's open on your Google Drive, then share that tab and that should work.
Oh, I want to say I live by Lake Michigan.
Mm-hmm. Yes, you do. I don't live by, there it is. Okay.
You can see it?
Yes, we can see it. So just put it in like Zoom or presentation mode so we can see it bigger. But we do see the presentation.
Yeah. I don't know if I can. Okay, wait.
I don't hear an echo.
No, I don't.
No, because she logged out herself. You heard the echo because she was in there twice. But there's no echo now.
Okay, but you can't. You still see the same thing?
No, we see your PowerPoint. We just can't read it that well because you either need to Zoom or put it in presentation mode. But we see the presentation.
Okay, wait. I still think this is the wrong thing.
Oh, it was the right thing, but you took us out. It was the right thing. You just needed to Zoom it so it could be bigger.
Okay, wait.
So you were exactly at your presentation.
But I think it's just showing my Google Drive, not my presentation.
No, it was showing your presentation. So I think you just needed to put it in present mode so that we could see your slides bigger.
Okay.
We saw your slides, yeah.
All right, I'm doing this again.
Okay. Yes, we got it. It's perfect now.
Great. Okay. Great. I am so sorry for all those technical difficulties. That's what happens when you get old and you're not as familiar with all this technology. But none of you listening will have this problem. Okay, so as I said, my name is Debbie Gordon, and I work with the U.S. Geological Survey, or USGS. And USGS is the nation's Earth Science Agency, and we have 7 missions Those are climate and land use change, core science systems, energy and minerals, environmental health, ecosystems, natural hazards, and water. And as I will tell you more in a little while, I work primarily with water, so I'm a hydrologist. So again, at the USGS, we provide science about natural hazards that threaten lives and livelihoods, the water, energy, minerals, and other natural resources that we rely on, the health of our ecosystems and environment, and the impact and land use change. Our scientists develop methods and tools to supply timely, relevant, and useful information about the earth and its processes. So these are just some pictures of me up in the upper right-hand corner working in the field, and some of my colleagues collecting and measuring some water data. So I'm a hydrologist and I focus on groundwater. And groundwater is obviously water that is under the ground. And we study aquifers for water supply. We collect samples for water quality and collect water levels from wells. So pretty much to get at groundwater, we have to drill a well and then put a pump in that well out of the ground to access the groundwater. And this is me at a well, one of the irrigation wells that I was collecting some samples from. So I'll tell you a little bit about how I got into hydrogeology. Basically, I've always loved geology, which is the study of the earth. And early on when I was a kid, my family took a couple of trips out west. So I grew up in Maryland and we drove across the country to, for example, Arizona, and visited the Grand Canyon. And this is a terrible picture of me and my sisters at the Grand Canyon. I'm the one on the left here. But here's a good picture of the Grand Canyon. And you can see at the bottom is the Colorado River, which carved the entire Grand Canyon, exposing geology going back to 1.8 billion years of Earth history. So each one of these layers represents rocks that were deposited further and further back in time. And when you get all the way to the bottom, the rocks down here are 1.8 billion years old. So I was really affected by all the rocks and formations I saw out west because they're not as much covered up by grass and trees and plants as the rocks are out here. So you can really see all the rocks. And I thought that was really cool. And I've basically been interested in geology ever since. And I've always loved collecting rocks and looking for treasures from inside the earth. So I decided to study geology in college, and in college I was able to take some really fun field trips. So these pictures on the left are from University of West Georgia, where I did my undergraduate studies. And this is a picture of the group. We piled into this van and drove out west to study geology and also collect some fossils and rocks. And that was a lot of fun. And I got my bachelor's of science in geology. And then I went to graduate school at East Carolina University and got a master's degree in geology with a focus on groundwater hydrogeology. And we also took another big field trip out there where we did a lot of geologic mapping in places like Arches National Park. And here's a picture of teeny tiny group that I was with under one of the arches at Arches National Park. And now I get to drag my family out to look for rocks. This is a picture on the upper left of my daughter and a friend of hers. We were looking for quartz crystals. And this is another picture at the bottom. And then the upper right is a picture of my husband and my daughter when I dragged them out to a big pile of rocks where we were looking for opals. Because my favorite gemstone is opals. I think they're so pretty. And we did actually find some, well, we found some rocks with some little specks of opals, but I was all excited. They kind of think I'm crazy, but that's okay. So we do a lot of field work at the USGS, and we have a lot of hydrologic missions, and I do a lot of field work myself, but the hydrologic technicians go out almost on a daily basis and collect data. So I'm going to show you a video that will give you an idea of what some of the hydrologic technicians at USGS do. Oh, sorry. Wait, go back. Wait, while we're waiting, I'm going to make it a little louder if I can.
I started off my career at the USGS as a hydrology technician, and when I took that job, I didn't know how an introduction technician did. So it's been about 3 years. Hydrologic technicians do a variety of work. It's field work, it's office work, and pretty much anything you can think of in support of collecting USGS water data. That's what our hydrologic technicians do. So a few of my colleagues will work in touches throughout the
Hey folks, my name is Hound, President of the United States Central Officer here in Washington State. I'm on the beautiful Correlate River, measuring stream flow. I'm using an acoustic doppler profiler today. This uses sound effects to measure water velocity and cloud data. This particular station is important for flood warning. The National Weather Service uses this data in order to issue flood forecasts and flood warnings when necessary.
Wow, this video is really well done. The sound is, we can't really hear the sound well. But I did want to ask, these are members of USGS from around the country, right?
Yes, they are.
Very nice.
Can you not hear it well?
No, we can't hear it well. The
Okay,
visual?
well,
Go ahead.
what? I mean, I can cut it off short if you would prefer.
That would probably. I
Be
mean,
better.
we could narrate. That would be also helpful.
Okay. I can do that. So this technician is calibrating a rain gauge. So when it rains, water fills up a bucket inside, and when it gets to a certain, when it fills up a certain amount, it tips over and it records how much rain has been collected. So she's just calibrating that. This guy works in Washington State, and he is measuring the stream flow in this creek. So he's going to collect the velocity, the width, and the depth. And then that data will be transmitted via the web, so anyone can access that data at any time. So, and he's saying that all of our data is free and available to the public.
And that's what I was just going to ask.
Yes, and water resource managers use it to help manage the water resources.
Would you be able to share the link to this?
Yes. Okay. I can do that. In fact, I have the link at the end of the presentation, but you know, however you want me to share it, I can do that. So this is an old gauge that was in operation until Mount St. Helens erupted, and the eruption kind of messed it up. And so he's trying to figure out if they want to redo this gauge or put in a new one. Okay, that's all of that.
Cool.
So Debbie, I have a question. So the guy at the stream, his hair was wet. So like, was he just sweating, or did he have to actually get into the water to do tests?
Actually, he said this, but I'm sorry you couldn't hear it. It was raining.
Oh, okay.
So, I mean, it doesn't matter, like in all kinds of weather, our technicians are out collecting data. And in fact, as this slide shows, we do a lot of work in floods. So
they're walking in the water.
These two technicians in the upper right are taking flood measurements and high water marks during one of the most recent hurricanes. So you can see like this road is totally flooded. And on this, the bottom right here, this is actually a road. And these guys are taking some measurements of some high flood waters. And then when the floods recede, we go out and look for high water marks to see how high the flood actually got. And you can see this line right here of debris. That's the high water mark from the last hurricane that we were measuring. So we make all these kinds of measurements so that during future floods, we're more prepared. And, you know, when people evacuate from their homes, we can predict where that will occur. The more data we get, the better we can predict future floods.
So I have a question, Debbie. What are they wearing to be prepared to walk through all that flood water? And what instruments do they take with them?
Okay, so just like fishermen, we put on waders. So they're like boots, but they go all the way up to your chest. So they're called chest waders. And so they kind of have like overall straps, and they're just like big rubber boots. So they can walk through, you know, pretty deep water without getting cold and wet. And in the video, they showed one of the instruments that we use to measure flow. And it's just like on a metal rod, and we put the instrument in the water, and it can measure how hard the current is going by it. We used to use like an instrument that had a little wheel on it, and the instrument would like count the number of clicks, the number of times the wheel went around and round. So, and from that measured flow. But it's got a little more sophisticated. And then that data gets uploaded to a computer, and we have that all that data available on our website.
Thank you. I was just curious.
Sure. Okay, so then after we collect water samples or data, we oftentimes bring it back to our labs and process the water. Like this picture on the left, two of our technicians are mixing the water with a churn to make sure we get an evenly distributed sample across the stream. So they'll collect samples at maybe 6 different points going all across the stream, and they'll put it in this churn and mix up the water, and then they'll send it out to a lab and have the water quality analyzed for different constituents like turbidity and lead and copper and different elements to see what is actually in the stream. And this is a map of Georgia, South Carolina, and North Carolina, which these 3 states make up the center that I work in, the South Atlantic Water Science Center of the USGS. And this just shows you all of the continuous data recorders that we have in these 3 states. So, I mean, we have so many locations where we're continuously collecting data. So that means we have a gauge that sits on the stream or at a well that's collecting water levels or stream flow. And at any time you can go on the web and see what the measurements are at any of these points. And we have data like this all across the country. So USGS collects just an enormous amount of data, and it's all available to the public. So, but like I was saying earlier, to study groundwater, we need to get water out of the ground, which is in aquifers. An aquifer is a rock that transmits water in a usable quantity and quality. So in the southern half of Georgia, people primarily get their drinking water from groundwater. Sometimes they get them from streams, but for the most part, groundwater. And where we are in Atlanta and the upper half of the state, we primarily get our drinking water from streams like the Chattahoochee and different reservoirs like Lake Lanier. So when I study groundwater, I'm primarily working in the southern half of the state. So, and like I said, to get the water out of the ground, we have to drill wells. So this is some pictures of a drill rig that I was working on. We were drilling some wells to study the groundwater in Southwest Georgia. So basically what they do is drive really long pipes into the ground. And here's a cartoon of that shows a well that goes deep into the ground, and the upper layers are just solid pipe. And then the aquifer that we're interested in will put screen, which allows the water to flow into the pipe. And then that water way under the ground is under pressure. So when that pressure is released, the water rises up in the well. And sometimes it rises above the ground and you can actually see it flowing out of the ground, like over here in this flowing well. And then we can put different instruments or tools down the well and send out different pulses or signals that measure certain things in the rock. And we can look at those signatures like these, and those different spikes tell us a little bit about the geology. Like certain spikes will tell us where there's more clay and where there's harder rock. And some of them will tell us if there's dissolved solids in the water. So we can learn a lot about the water and the geology underground using these tools. And they also use groundwater in the southern half of the state, primarily for irrigation. And these are just some pictures of some irrigation wells. This is in a cornfield, and this is a cotton field. And these are the wells. This is a well that we use to monitor the water levels. And this is a well that is used for irrigation. We also do tests on the aquifers. We can put a pump in the well and pump it at a certain rate and then measure how fast the water goes down in the well. And we can plot up that data and learn like how much water that well will supply and for how long. Okay, I have another video here. Do you think I should show it, or would you rather just ask questions?
If it's something that you can narrate, show it if the sound doesn't work. We do have some questions in the chat, but I think the video will be good. And then you'll share it with us later, right? The video?
Yes.
Okay.
Yeah, and this video is just some of the accomplishments that the USGS has made only in 2020, just during that 1 year. And because we do so much more than water, which is my specialty, we do some other really cool things. So I'll try to point out the highlights as the video is going along. So we have over 8,000 employees. So we have an earthquake early warning system that will let people know when an earthquake is coming. So we're just testing these. We're doing one in California and one in Oregon, and then hopefully we'll expand that. So Mount Hood and Mount Rainier. So we let people know where there might be debris flows after the wildfires out west. This is hurricane work. We put out sensors to measure the high water marks during the hurricanes. We've mapped 85% of the streams in the US. We monitor coastal change. This is about invasive species. These are invasive python blades. We're helping to detect disease in deers. We do a lot of 3D mapping. We help to map Mars for the Perseverance landing on Mars. We're mapping lithium and other rare earth elements that are used for batteries and electronics and renewable energy. We're looking for geothermal resources. we have a big project coming up on the Colorado River Basin. Okay. Does anyone have any questions about that video? Which I'll provide the link at the end.
Cool. We did have a question. Does soil erosion correlate with hydrogeology?
So hydrogeology is primarily dealing with groundwater, but soil erosion is very important and related to hydrology because when it rains and there's not a lot of vegetation, like in highly urban areas, a lot of soil erosion and runoff from the rain, and also like floods. I mean, that produces a lot of erosion.
Okay.
So I just have a couple more slides, and then I can answer some other questions if anyone has them. But this slide shows that anyone can be a steward of the earth, and we can all do our part to keep the earth clean and healthy and help our water stay clean. So you can participate in trash pickups, dispose of waste responsibly, like recycling what you can, avoid using plastic when you can, pick up pet waste, use less water, plant trees, limit the chemicals that you use on your lawn, and use environmentally safe products. Like the less chemicals you can use, the better. So those are things that we can all do. And I have the videos that we saw, plus another video and some resources on this slide that anyone can access. So USGS has a lot of educational information, water information, earthquakes. I like this one because it shows where there was an earthquake pretty much anywhere in the world. And when I looked at it for the first time a long time ago, I was surprised to find out that we get quite a few earthquakes around here. I don't know if anyone has ever felt one. I felt one many years ago, but like when I was sleeping in Atlanta and I was woken up and I'm like, I'd never felt an earthquake before, but I'm like, I'm pretty sure that was an earthquake. And it just surprised me that we do get earthquakes even in this area. You know, not quite like California, but still interesting. So that is all I have as far as slides. So I would be happy to take any other questions.
I have two burning questions.
Okay.
So the first one is, can you talk about, the difference between, I feel like the work that, I see and that you've mentioned deals with not just weather, but climate, that you put climate, but, for those who are not as, knowledgeable and educated on basically my question is, from the work that I've seen, it seems like there's overlap between like what a meteorologist would do, or the type of information that a news a weather entity would provide, So can you talk about the difference between like the data that you guys collect on like floods and everything compared to that? Because it seems like it's definitely different. So what is the difference?
Yeah. So first of all, we work very closely with, for example, the National Weather Service. You know, we share each other's data, which is very helpful. But, you know, like I mentioned, we measure, rainfall and rain gauges, and also floods and stream flow from hurricanes and other events, or just heavy rain events. And so we can give our data to the National Weather Service, and they can put it into their models that help them predict future weather. So they also collect rainfall data, and we use their rainfall data to help us know like where to put our gauges and things like that. So, you know, we can do our best science when we work together and share our data. So hopefully that answered your question somewhat.
Yes, I think it definitely did. And
Okay.
then my one other question was, when I was Googling on, you know, the subject of hydrology, I was surprised to see that one website said that, you know, math skills were necessary and statistics skills were necessary. And even from some of the photos that you shared with us, some of the images, there was, you know, just looking at how you guys compile the data you know, was really interesting to me. So I was wondering if you could answer, you know, what different aspects of STEM skills are necessary when you're going into hydrology as a career.
We do use a lot of math and a lot of graphing. We use a lot of graphs and statistics. So it was interesting, you know, since we've all been doing a lot of working from school, from home. My daughter has been doing her schoolwork at home. And I remember, I guess it was last spring when she just started having classes at home. She was like kind of complaining, you know, why do I need to do this math? She was having to graph up some data. And I was working like right next to her on my work. And I turned my computer to show her that I was actually using a graph almost exactly like her homework problem. I'm like, well, I use this graphing method all the time. And so I could say, you know, see, people do actually need to learn this. So that was a good moment for me. But so math is very helpful. And, you know, we use computers for everything these days. And I wish I was better at computer skills because, you know, back when I was in college, we didn't use them quite as much like we do now. So any, you know, math, science, statistics, and computers, and also geography is very helpful because, you know, everything that I do, I pretty much need a map to either get there or show the data that I'm collecting. So all those things are really helpful.
Wow, that is so surprising to me, but so cool to know. So my last question is, what advice would you give to someone that is interested in hydrology?
Yeah, definitely pay attention to those math classes. And it's basically, you know, people might have to take a lot of math in school, like calculus and those kinds of things. And sometimes we have to use that, but mostly, you know, it's a lot of geometry and algebra. graphing that we use on a daily basis. So, yeah, if just learn as much as you can about math and science and computers. And also GIS, Geographic Information Systems, which is basically using computers to make a map, is so helpful these days.
Okay. I feel like
I
that
have a
is
question.
Okay.
I have a question. So I have a map in my car because one of my mentors is like, you cannot depend on your GPS. So like you said, kids should learn GIS, but is it a benefit of them learning how to use just a regular paper map or atlas? And if they do that, like, how do they get started? Do they pick up the same one at the gas station or Walmart like I do, like in your road trips? Or is there a special map that they should buy somewhere to get familiar with the geography or geology? Geology, maybe both of them. I don't know.
I mean, a good place to start is getting a road map, like you said, from a gas station, because really maps are not difficult to read. You just have to be familiar with them. You know, look at the map, familiarize yourself with the different symbols that are used on the map. You know, get used to like the direction, you know, where north is. If you have north paint facing upward, it's always helpful to me so I can orient the map. And also, yeah, if that GPS goes out, it is really handy to have a paper map.
Do you do your field work with a paper map, or any of the scientists that do the work in your field, do they have to travel with a paper map as a backup? Except the flood people, because the map will get wet, right? But
Right.
anybody else?
Yeah. So I always take a paper map of my field sites with me because I find that, but I also use my GPS to help get me to a location. So that has definitely made things easier, you know, especially when you're going from one site to the next. But yeah, I'd say most people also use a paper map. And it's helpful. I don't know if you've ever driven through an area where your GPS just has no idea and it just shows like this huge blank space. Sometimes when we get like way out of town in the middle of nowhere, the GPS does not know. Like those roads might not have been mapped. So if you have a good like county map that shows the county roads, which sometimes are numbered, you know, not even named, then it can be really helpful.
That definitely sounds like an adventure. And even from the presentation that we saw this evening, I love the environment. I love nature. So I was just like, this job looks amazing for that, because I was seeing like the sunset in the sky. So hopefully, you know, the kids that watch and also have a love for working in the environment will consider this as a potential career. So we want to thank you so much for, you know, staying in there with us, because that presentation really was awesome. So we're so happy that we did it.
Good. I'm so glad too. Yes, and thank you both for your patience and perseverance.
It happens, but it was well worth the wait. You had some great videos and pictures that allowed us to get a really good feel of what hydrologists do, because I didn't know. I was just like, it's something with water.
Right.
So we definitely got a picture of that from your talk. So once again, thank you so much, Debbie, for making time to do this. It was just amazing, and we learned so much. And I just want to thank everyone for tuning in, whether you were live, especially if you were live, for your patience and hanging with us
Yes.
through the technical difficulties. We hope you learned so much, and those who are watching it later on YouTube channel, just thank you for tuning in and learning so much about hydrology. And we hope that if you were interested in, like, being outside and interested in math and science, you can learn that, like, not everybody who does science works inside or with a lab coat. Some of us, some scientists, not me, because I was a chemical engineer, I didn't do anything outside, actually do important work for our environment and outside to help us study the world that are around us, especially hydrologists, because they, with our clean water, right, they help make sure we have clean water and that water is flowing to us. Because I could imagine if the Chattahoochee dried up, or maybe this is the last question I do have. This is so crazy. So remember that Florida, Georgia, and Alabama were in court over the
Yes.
Chattahoochee, and I think Georgia won. So how does that go into hydrology, and why was that court battle like so important for states' access to water?
Yes, I mean, that has been going on for literally decades. And even though Georgia did get a very significant victory, which I'm so happy to hear, there are still other court cases about Florida, Alabama, and Georgia still going on. But this was a big one. And the courts said that there was no proof, or Florida could not prove that Georgia was affecting their habitats for their fisheries. That's what they were mainly concerned with. So they said that Atlanta was using too much water, and the farmers outside, like in Southwest Georgia, were using too much water, and it was causing some of their fisheries to not survive. So, and they just weren't able to show evidence that that was the case. So we actually, the USGS provided a lot of data that went into, showing that how much water Georgia was using and how much water Florida was using. We did a lot of hydrologic modeling with the data we collected to help in those cases. Water is a very contentious resource.
Yeah, thank you. I just was like, oh, let me not go before that court case, because I remember hearing it forever, and I'm from Florida. So I was just like, wow, you never think these water, it's like states are fighting over water. Like, this is interesting.
Yeah, and we're blessed here. We have a lot of water. We get a lot of rain, but it's still such a valuable resource. But like out west, they've been fighting over their water forever because it's so dry, and it's a lot harder to manage when they don't have enough of it to begin with.
I can imagine. So your job is super important. So if you want to be a hydrologist, your job is super important. Well, thank you so much, Debbie, and thank you for tuning in. And we all will see you at our next cafe. That's right, the next event, or we do.
For this month, we have, first of all, we can't go without mentioning our Atlanta STEM Career Fair happening this Saturday. We are actually going to hear more about the work that USGS does there, as well as other STEM disciplines. And so you can go to our social media accounts. If you're on Facebook, look on Facebook, Instagram, where we have the link to pre-register, where we'll be having the career fair virtually on the Hop In platform. And so that will be from 10 a.m. to 1 p.m. on Saturday. Also for this month, we're going to be hearing more about birds and yes, more on birds. And so with that, we definitely want you to register for those on our Eventbrite page. And those are the events that we'll be having coming up. So
well, thank you. Go say, I'm sorry.
No, I was just going to say, please make sure you fill out the survey, and we will catch you next time.
Catch you next time. Thank you, everyone. Bye.
Bye.
Thank you.
You're welcome.